Okay, my name is Mark Volkmann. Volkmann, I can't even say my name correctly. And I'm going to be talking about Strata, the Node.js-based web server. And I'll be coming in and out of view of the camera as I go to my keyboard to switch slides. But one thing I want to point out is that I don't know everything about Strata. I think I know a fair amount about it, but I'm sure to say at least one thing that is wrong. And feel free to correct me as I'm going through this. And for those of you watching out on the web, shoot me an email here and we'll get everything fixed up. Strata is a streaming server, and we'll be getting more into what that means later. But basically, you can serve up large amounts of data and not have to hold the whole thing in memory at once. And it's based on some other things that have come before it, a Python-based server and a Ruby one, written by Michael Jackson, not the pop star, but some other guy who works at Twitter. And he also contributes to the Mustache templating engine. And here's the main website. And when you go there, this is what you're going to see. The manual for Strata is pretty well written. And of course, you can check out the source code. This is a node-based thing, and so maybe some of you don't have experience with Node, and these are just some of the basic things you do in order to use any Node module. So first you need to install it, and Node has this Node package manager for doing that sort of thing. And so you give it the name of the module you want to install. The -G here is just controlling whether you want to use this for all of your projects and put it in a global place, or whether it's just maybe for this one project you're working on, and then you omit that. And then separately in your code where you want to use this, you need to require the module, and that's what it looks like. One of the big things about Strata is that it supports a concept of middleware. Maybe the way they use the term middleware isn't the same as how other people use it. And Strata, what this means is that it's a JavaScript function, and that function is going to get called when a request comes in, and it gets a chance to do two basic kinds of things. It gets to see the request information before it actually gets processed, and then it can modify things about the request. And then it gets to see the response from the processing before it actually goes out to somebody's web browser, and it can modify the response that's coming back. So if you write one of these kinds of JavaScript functions that follow very specific rules, and then you want to use it, you call strata.use and you pass in reference to your middleware function, and you can pass some arguments to that middleware function to kind of configure it. So we'll be getting much more into middleware coming up later. So some of the reasons you might choose to use Strata over some other web server frameworks that work in Node. First is that it supports streams. I talked about being able to process large amounts of data and not have to hold it all in memory at once. The other is this middleware concept that lets you jump into the flow of the processing and modify requests as they come in, responses as they go out. You can do that in some of the other competing products, but it's not quite as easy as it is here. And so, for example, Express is another node-based web server that kind of competes with Strata, and it's not very easy to do that sort of thing there. And that's one of the reasons that on the project that I'm working on now, we decided to stop using Express and switch to Strata. And then a final benefit is that it makes doing certain kinds of mock testing really easy. So for some people, you may only care about the basic uses of Strata. And so I want to start with that, and then as it gets more complicated, you can kind of zone out if it's beyond the things that interest you. But the most basic thing that you might want to do is just serve up some files. One reason to do this is that you might be testing something where if you access some of your server code from a local file, like you just got an index.html file and you open it as a file, and then that's going to talk to things running in the server, you can get this problem with accessing a different domain. And so to get around that, you could just serve up your HTML from this server. And so this is a very easy way to do it. You just have to say that you want to use this middleware that's called strata.file, and you give it the path to the directory that contains your files. It might be a directory with a name like public that is holding your HTML files and images and whatever. Now you can also pass a third argument to this, which is the name of the file that it should use if you don't specify one. So if I give it a directory, and then I go to my server, but I don't specify /index.html, I could set that up as the default. I also can pass it an array of strings, and it'll just attempt those in order if all I've given it is a path to a directory and not a specific file name. If it doesn't find what I'm looking for, well then this middleware essentially does nothing, and the request goes on to possibly other middleware that might do something with that. There's a second way that you can set this up, but it's not really important to talk about this. It's just an alternative to the line you see here. And then finally, you might decide that you want to serve up a directory listing if someone doesn't give you the name of a file. Then they can see hyperlinks to every file in that directory and then click on one to get to it. And if you want that, there's this other provided middleware, strata.directory, and give it that same directory path. So let's look at a full example of taking advantage of this. So here is my server.js file. You can name that anything you want. That's just the name that I chose. So the first thing I need to do is pull in that module, and then I'm going to register this middleware to serve up files. I'm looking for a directory called public, and if I don't tell you a file to serve, index.html is my default. I also want to provide directory listings, so I'm using that middleware, looking at the same directory, and then I tell Strata to start running. And by default, it listens on port 1982. Turns out that is the year that the author of Strata was born. So you just pick that. So this is the setup that I have. I've got this directory called file server, and inside that is my directory called public. I've got an images subdirectory. There's one image in there. I've got index.html, which just has an h1 tag with whippets in it, and then an image tag to display this picture. And then I have my file server.js that you see up there. And so I go to a terminal window and I say node space server.js. It starts up my server. And then in my browser, if I hit this URL, well, I didn't specify a file name, so it defaults to that, reads in this index.html file, and that's what I see. If I give that URL with /images at the end, well, now I'm hitting a directory. And so I get the directory listing. There's only one file there. I could click that and go to it. And I could also just type that in directly, either way. And so I bypassed the index.html and just brought up the image by itself. So as I just said, to run that, I just say node server.js. If I wanted to use a different port than that default, then when I say strata.run, I could pass it this JavaScript object where there's all kinds of configuration I could do. But one thing is to tell it to listen on a different port.
How does it actually perform as a static file server? I mean, would there be a reason to actually use it in that way, or is it just for convenience when you're developing?
We've never actually hit it really hard for that purpose, but I haven't noticed any performance issues.
Okay.
The next thing that you might want to do, kind of moving up the levels of complexity, is to start to do some routing. So here what I care about is that when I get a request with a certain HTTP verb, it's a get, a put, a delete, something like that, and then the path that they're hitting matches some pattern, then I want to process it in a certain way. And so I can say strata.method, where method is one of those things. And then I can give it a pattern, what the URL needs to look like, and that pattern can be a string or a regular expression. And then app is just a JavaScript function that's going to get a chance to construct the response for this request. If I want to use the same app for multiple methods, then I can use strata.route instead. I give it the same kind of pattern in the app, but then at the end I can give it an array of method names. So I could say this is the same thing you should use whether it's a put or a post, for example. Now this one, where I'm giving it specific methods, actually internally it's just calling strata route for you and supplying that third argument. You can also just give this a single string instead of an array, and it will use just that one HTTP verb. Well, it turns out that when you set up a bunch of these routes, of course, you still might get a request that doesn't match any of your routes. And in that case, you can set up strata.run and give it an app. And this is kind of like a catch-all. Anything that didn't match a specific route would get handled by that. So here's some basic examples of doing some routing. So the simplest thing I could do is require the Strata module, and then here I'm just going to set up one route listening for the path slash. So you've just went to maybe localhost 1982, and this is going to get invoked. So in this first example, I'm doing everything myself. I'm not asking Strata to do any work for me, really. I'm going to tell it what the content type is that I'm serving up. I'm going to serve up just plain text and the length, and then I'm giving it a string that is 12 characters long. Here's my status code. That's an OK status code, and then the headers I'm passing in, and then I just tell Strata to run. And if I hit that, I get back the string hello world. Now, taking this a step further, I don't need to explicitly tell it the content type. It can figure that out based on what kind of data I gave in the response, and I don't need to tell it the content length. It can calculate that as well. So to do that, I use these other provided middleware, content type, and it takes another argument that is the default content type in case it has no way to figure it out based on what you put in the response. And then content length is telling it you figure it out yourself.
Is the content type middleware, is it smart enough to look inside the stuff that's coming up out of the file, for example, or the response that's being constructed and say, was there a doc type declaration at the top, that kind of thing?
I think it is doing that sort of thing, but I haven't actually looked at that code.
Okay.
And so now, the app part of this, which was several lines up here, is now really short. I just say it's a 200 status, and I don't have to pass any headers because the two that I needed will be provided for me, and then the content that I want to respond to.
So by passing it that empty anonymous object, you're actually telling it to use its middleware. It's not overriding. See what I'm saying? The CD200, open curly, close curly.
Right?
I mean,
So you have to pass it an object there, but there doesn't have to be anything in it. But the fact that I've registered the middleware is going to cause those to kick in. Now, what would have happened if I would have specified a content type? Would this have been smart enough to not override it? Boy, it sure seems like it would do that, but I can't say for sure.
I think it does. I think I've seen the code, and it looks to see that it doesn't have a content type, it creates one, but if it already had one specified, then it'll use what it has. So if you give it any content type or length, I think it's going to use what you gave it first, and that's just kind of set default stuff if it doesn't, if it doesn't have
so
it.
it's like a back stuff.
Yeah, and so and that also could include other headers, that you might need to set. So that, be setting cookies or other kinds of things that could be going back as well. You just, optionally wouldn't have to do content type and length.
Right. So a couple of things that we've seen in these examples. We've seen this env, and we're not doing anything with that. And then we see that I'm invoking this callback. So I wanted to say a little bit more about that. env is this JavaScript object that holds all kinds of information about the request. And remember I said that when you're writing your own middleware, you can change things about the request before it gets processed. And that's the key to doing that, is you modify properties that are in that env object. So examples of things that are in there are what was the protocol? Was it HTTP or HTTPS? What was the verb that was used? What's the path? What are the query parameters? All kinds of things like that. So when we get to slide 14, we'll see more detail on that. And for the callbacks, you see that the pattern is you have to pass it the HTTP status code and an object that holds headers, and then whatever response data you want to send back. And in my examples, that has been a string, but it can also be a readable stream, which is a very specific node.js thing. So we are going to see one example of a node.js stream coming up in a later example. Now, what I'm showing in this example is that catch-all function, strata.run. So if I don't have any route specified, here I'm specifying a route, and here I am. But in this example, I have no routes, so the catch-all will come into play. And it's very similar, it's just that you have a little bit more work to do, and you get some added flexibility for that extra work. So here I'm going to create a response object. I didn't have to do that over there. I just passed a string for the callback. But here I'm going to put my content inside a response object. And then there's all kinds of properties I can set on the response object to tell it things like content length and content type. And then when I'm done, I don't directly invoke the callback. Instead, I pass the callback to the send method of the response. So it's a different way of dealing with a request coming in. And you have some added flexibility because of all these things that you can set on the response. So I'll be talking more about that later.
What's the ENV variable?
ENV holds all kinds of information about the request that's come in, like the HTTP verb and query parameters and those kinds of things.
So roughly similar to the request object in the Express framework? I mean, similar to the request object? I don't see a record.
Oh, right. The ENV is similar.
Yeah.
Right, exactly. Now there also is a Strata executable. In my earlier example, I said, well, to run this, you just say node space server.js. If you want to use the Strata executable, then you write your code a little different. You wouldn't be calling strata.run. The executable is handling that for you. And instead, you give it a JavaScript file that does something like this. It's going to export a single function that is the app function that you would have passed, say, to a route. So you write a little bit less code, but I haven't really seen much use for doing it this way. Of course, if you do, there's some other command line arguments that you can specify. So just an alternate way of running your Strata server. Another thing you can do with routes is specify parts of the path that you want to extract because you're going to use them in your processing. So for example, if I'm expecting a URL that looks like /student/ and then an ID of a student, the fact that I put that colon in there means that I can easily extract that part of the URL. So I just put colons in front of names, and then when I want to get them out, I say env.route. and the name of the thing. So here I'm pulling out the value of ID. That's one way to get data from a URL. Another way is that I can just grab the whole path with env.pathinfo and maybe match it against a regular expression to pull things out. So here's an example of using that. So I want to be able to specify a mathematical operation in the URL and then slashes and some numbers and then have it operate on those. And so I'm going to pull those out and add them. Of course, it's 24. And over here, I don't have div supported yet. And so it's going to see what the operator was and going to give me an error message like that. So here's the code I need to do this. First of all, I've got some constants for some HTTP statuses. So for the div case here, I want to send back a 400 status code. I got a bad request. But over here, I want the OK status of 200. I'm going to use those two pieces of middleware we saw earlier because I don't want to figure out the content type and I don't want to calculate the length of my response. I have just one route. So I'm looking for /add and then I want two numbers. And so I'm going to put those in N1 and N2. And then the first thing I do is try to grab those and parse them as integers. So if they're not present, or if they are present but they're not numbers, when I do that parse, the value is going to be the not a number special value. So I'm checking for that. If either one of them was not a number, then my result is going to be that the path parts after add must be integers and I got the bad request status. Otherwise, I can add them together and say the sum is that, and I've got a good status. And then I'll invoke my callback, give it the status that I selected. I'm not specifying any headers. There's nothing special I need there. And then the results. Now I have one more piece here, and that's the run piece. Remember, this is like the catch-all. So if I have a request that doesn't match this route, then it's going to go down here. So I can go to the path info, which is the whole path of the request. And I want to find that first piece, because I'm guessing that that was an operation that they wanted, but I just don't support it yet. So I'm going to pull off the first character of the path, which would have been a slash. And then I'm going to split the rest of it on slashes and grab the first piece. And that's the operation they requested. And then I'll say that that operation is not supported. And then I give the bad request. Questions about that? So back to that environment object. This is not a complete list of the properties that are there, but it gives you a good feel for what's available. So as I said, the protocol that it was requested with, the request method, the name of the server, the port, the whole path, the query string, any headers, where did the request come from, and then an input stream and an error stream. So the input stream, if I'm having data streamed to me, then I can listen for chunks of it coming in a little at a time. We'll see examples of a stream coming up later, but basically I just have to listen for data events as each piece comes in, and then I'll get an end event when I've received the last one, and then I can operate on that data. And then if I'm working with sessions and I have session data, there's a place where that is stored in the environment object. So now I want to look at a quick example where I implement something that's kind of RESTful. So what I want is to have a server that is just storing data in an object for me. And so I can say, take this key and this value and hold on to it for me. And then later I can retrieve it, or I can delete a key, all the basic RESTful kinds of things. So I can operate on this just with curl in this way. So here I'm issuing a put request, and here's my URL. So my service here is called list, and then this is a key. And then the content that I pass in this case it's JSON data, it's a JavaScript object, name is Gretzky, number is 99. So I'm going to put that into my collection of data with the key of player, and that's the value. And then I'll do that again, the key is dog, and the value is not JSON, it's just a plain string with the name Rudy. So after I've done that, I can do another curl, and this is going to default to being a GET request. And I ask for the list, and I get back this JavaScript object that's everything that it's stored for me. I've got a player, and I've got the dog. I can ask for a specific one, just the player, just the dog. Here I'm deleting the player, and then if I ask for it, I get nothing back. And if I ask for the whole list, of course, only the dog is there. So that's what we want to implement in this example. So a bunch of constants for some status codes, and then here's the list where I'm going to store the data. And if I get a put request that matches this, /list/ and then there's some key, then what I want to do is get the value of the key. So env.route.key pulls out the value that matched right there. Next thing I want to know is what kind of data did you give me? So I'm going to the headers that are stored in that environment object, and I'm asking for the content type. One thing to notice here is that Strata likes to make all of the header names be lowercase. So it doesn't matter what it really was, it's going to lowercase it. And so you have to know that when you're asking for them. So if it was application JSON, then this is going to be true. Otherwise, it will be false, and I'm going to assume it was plain text. Next, I want to read in what was in the body of the request. And remember we said that Strata does streaming. And so I'm just going to get a bunch of data events and then an end when I'm finished getting the data. Well, you get this through env.input. And initially that stream is paused. It's just waiting for you to set up the listeners. And once you have them set up, then you tell the stream to resume and you'll start to get those events. So I start out, I don't have any of the data yet. And then I say, if I get a data event, what I want to do, I'll be passed a buffer. It's not a string, but it's this other kind of node data structure for holding on to data. But you can call toString on that to turn it into a string. So I've got a buffer, turn it into a string, and just concatenate it to the body. And I don't know how many times this is going to be called, but I'll just keep concatenating the pieces. And finally, when I've gotten them all, I'll get an end event. And then I'm going to say, if the content type was JSON, then I want to parse that body and get back a JavaScript object. But if it wasn't JSON, I'll just use the body as it is, as a string. And that's the value that I'm going to associate with that key. And I'm just storing it into this JavaScript object. And then I'm going to send back my response, which is no content. It's a 204. It's a successful response, but I'm not sending back any body. And that's why I have an empty string here. So that's all I need to put something into this. If I want to retrieve something, if the path is /list, that means you want everything back. And so I can just do a JSON.stringify on list on this object right here. and pass that back. And here's my content type, it's application JSON. So I'm not using the middleware we saw earlier to try to figure it out for me. I'm being explicit and telling it that. And that's a good status. So that's my put and my get. Here's another get where you say /list and give it a key. And in that case, I'll get the key that matched right there, and I'll pull out just that specific value. And maybe you ask for a key that doesn't exist. If it does exist, then I stringify that and send it back. But if it doesn't exist, not found is the status. And then I'll have this message that that key was not found. And the final route that I need is for deleting. So if I get a delete request for a specific key, then I'm going to see if that value was there. If it was there, I'll delete it and send back a successful response with no content in it. But if I couldn't find the thing you asked me to delete, I'll give back the not found status. And then finally, I have strata run, my catch-all, if I get a path that doesn't match any of those routes. And in that case, I'm just going to say that with that method that you're using, and with the path info that you've asked for, I don't support that. And you get a bad request back. So that's a pretty complete example of setting up various routes for handling things and doing the basic RESTful thing.
I had a quick question. On the previous slide, and you may have done this just to keep things simple, but where you're testing the JSON parse, list key equals is JSON, question JSON parse. If that wasn't proper JSON, that would throw an exception, right?
Yes, it would.
Okay. So you'd actually have to wrap that in a try catch.
That's right. Yeah, that would be a good idea to do that. So I'm trusting that if someone said it was JSON, it actually was. But yeah, I shouldn't trust like that. And that's a good point.
And the data collection, you shouldn't do a two-string there.
On the buffer?
Yeah, because it might be not a full string. If it's like a UTF-8 character that's not in 1 byte, it could be split across two buffers, and then when it will end up being the wrong
You
size.
just have to wait until the buffers finish.
So,
And then call two string on the body, we get everything simple.
so like what a lot of people use is they just keep an array of buffers, and then on the end event they use buffer.concat and pass it that array, and then you get back a buffer that has all of the other buffers concatenated together.
Huh. Okay.
Now, Mark, is there any sort of, let's say we're fielding multiple put requests over a period of time. I'm not sure how the persistence of this server actually works. You're assigning event handlers to env input on, env input on, does this stuff all get cleaned up and go away after each request, or would we actually end up stacking up?
So the only thing that's sticking around is the list up here. For every request, I'm getting a different env object.
Okay, that actually.
Right.
Should we go back to Parrot's point? I mean,
Sure.
do you have to go back and change your code to handle multiple buffers?
Right, so this is only an issue if the kind of data I'm getting in, let's say it's not ASCII data. If it's all ASCII data, everything's good here. But if I get Unicode characters that are possibly going to spill over the edge of the buffer, then that's where I have a problem.
Well, it's more when they get split across into two different messages.
Right.
So it's not that hard to change. You change the body equals to an array, and then you just do body.push with the buffer,
Right.
and then on the end, you just do the concat, and then you get the, so it's not much of a change.
Yeah. So for everybody giving me these great suggestions, I would appreciate it if you could also email me a reminder about these tomorrow so I can update these slides. Okay. So we talked about how there's this response object. There's also a request object. So you get the env, and there's lots of good information in there. But for some things, it's easier to get out if you let a strata request object help you. And so here I'm making one of those from some env object that I've been given. And that's going to make it easy for me to work with things like multi-part bodies coming in, or pulling out query parameters in an easier way. So what you do here is you take this request object and you call query on it, and you give it a callback function, and it's going to pass to you all the parameters in an object, and then you can make use of them. And we're going to see an example like that coming up. If your parameters are in the body instead of in a query string, you use the query, use the body function here. And if they're mixed and some are in the query string and some are in the body, then you can use the params method on the request to get to those. We talked about responses already. This is just a little bit more detail. The content that I want to send back, I can wrap it in a response, and then I can specifically set some of these properties and set headers. And the most important part of this is that when you're finished working with the response and you've set or added headers in these ways, maybe remove things, test to see if headers are there, work with cookies, do redirects, but finally the important thing is that you call send on that response object and give it the callback that was passed into that route, and then that'll handle giving it to the place it needs to go so that you get your result. Okay, this is an interesting example because it shows how you can check to see if any of your data has changed since the last request and avoid serving it up multiple times. So here I have just one route for /dasher, and if you ask for that, I'm trying to serve up a JPEG file. But if you ask for it again and the file hasn't changed, then I want the status to be 304 not modified. So the way that I'm doing this is I'm using another feature of Node. It has this module called fs for file system. And fs has this function stat, and you give it a path to a file and it gives you back statistics about that file. And one of the things it knows is the modified time on that file. Now, I also can get a header passed in through this environment object, the if modified since. And so I can know when the last request for this has come in. And so I've got that date, I've got the modified time, and I can compare those. And if the file hasn't changed since the last time it was requested, then that's what I'm sending back. But otherwise, if you've never requested this, or the file has changed since the last time you've requested it, then I want to read from the file. And here I'm reading from an image file, reading in some binary data, and this gives me back a stream, and I create a response that's looking at that stream, and then I'll say that I'm getting back image JPEG. And actually, you see this line is commented out, and that's because the browser is smart enough to figure that out when it sees the data coming back. That stats object that I got back here also knows the size of the file and the modified timestamp on the file. So I'm setting last modified in my response, and then send it back. And then that starts up the server. So this is the one demo that I wanted to do. So here I have that server running, the code that we just looked at, and I'm running in Chrome, and so I've got the network tab selected here, and I'm ready to ask for dashes. And so what we expect the first time is that I should get my image back and my status should be 200. Okay, it's hard to read, but there's my status, 200, okay. So now if I just hit refresh, I should see it hit that again, but I should get a 304 this time. And there it is, 304, because the file hasn't been modified since then. So, you know, a fair number of details to get right, but that was a short amount of code to do that kind of thing.
What is the nature of that status.R response? I mean, is that, I mean, you're using it as a function, so clearly it's a function. This Strata's not status,
Here?
sorry, Strata. No, the Strata.response.
Down near the bottom.
Down at the bottom, var res equals Strata.response.
Oh, right here.
What- is
It's
that
like
just-
a constructor.
Okay.
Yeah.
I mean, is it holding on to a state or something like that from, between the different aspects of,
Yeah, the res that I get back is an object with lots of properties on it, and it has some methods on it. Yeah.
No, it's not holding state though. That's a new object that's being created right here.
Right. Every time I call it, I'm getting.
I'm just
new.
trying to understand how if you had multiple layers in your application and you needed to do similar things with Strata.response and multiple layers, how would they not get in each other's way? Or I probably just misunderstand.
Well, you could pass that res object around and let different pieces of code operate on it before you call send.
Oh, okay.
Yeah, you could do that. I don't actually like this way of writing JavaScript code where you have something that's a constructor, but you make it so that you can use it without calling new, and it still makes an object. I don't really see the point of that. So
Might make more sense to like create response or something like that.
but that's essentially what's happening here. Okay. Do you have another question? Okay.
So back your time.
Yeah. Okay, so you can do some fancier things here, and I'm about out of time, so I'm going to whip through the rest of this. You can do some custom error handling, and the biggest point to this is that there's this issue in JavaScript when you do lots of asynchronous things that if a problem occurs, you lose the stack trace. Well, this is the Strata approach to helping out with that. So if you report an error using this approach where you are making a class that inherits from strata.error, then it'll hold on to the stack for you and you get more information when there is an error. So this slide is focusing on creating custom error handling classes, and that's fine, but you can also use this thing called the global error handler. It's just this function strata.handleError, and then what they recommend that you do is if you're in your code and you have this variable error that you may have set to something or maybe you didn't, then you test to see if there was an error, and then you call this function, and this can return true or false. If it returns true, it means you want to stop processing now, and if you return false, it means it's going to report the error, but you're going to keep going. Well, strata.handleError, the default one, always returns true, and so it's kind of silly to write this code, but the point is you could override that to do something different. So the default one is always going to give a status of 500. If you want some other error status, then you'd have to overwrite that function. And while you're doing that, maybe sometimes you want to return false and continue processing. So again, the main point of this kind of error handling is that it preserves the stack trace for you. So I talked about Strata Middleware already. And one of the main features of this is that you get to intercept a request coming in and possibly modify it, and a response going out and possibly modify that. We talked about how you register them with strata.use, and you give it your middleware function, and then if you want, arguments that you pass into the middleware function to configure it. So that's the basics. You can also tell...
Is your stack trace stored in your EMV object? So if you go back one slide, 23. Is the stack trace then holding your EMV object?
I don't actually remember the detail about that. Here what I'm saying is that it writes it out to the error stream.
But if you wanted to inspect the stack trace and handle,
Yeah, I don't know if it is available to
things
you.
differently.
Yeah, I'm not sure about that.
Sorry,
That's okay.
process slowly.
Another thing we can do is ask Strata to log all the requests that have come in, and we're going to see that in the next example. So it's just a piece of middleware. You tell it to use the common logging middleware, and you get that functionality. So in the output that you see on this slide, this black line right here, that was logging one of the requests, and this is logging another one. And so what I want to demonstrate in this simple example are the pieces of middleware and when they get executed. So this file here is mw.js for middleware, and then here's my server. And notice my server requires this middleware, and then it uses it right there. And I'm passing in one argument, just a string foo, that is some kind of configuration of the middleware. And the thing to notice here is that my middleware is just a JavaScript function. It can accept parameters, and then I can show here that I actually got that parameter. And then the middleware has to return a function. And that function has to accept an env object and some callback that the response is going to end up going to. Inside the middleware, here's where you could do anything you want to the request because you have the env. And so you could change its query parameters, you could change the path, all those kinds of things. Then you are required to invoke app. Well, app was passed in up here, and that got captured via closure in JavaScript so that this function is holding on to a reference to that. Even though I've returned the function, this hasn't been executed yet. It's going to remember that app that was passed in and was in scope when this function was created. So here I can change the request. Then I run the main part of my application that's going to do the processing of the request. It will pass to me the status and any headers and the body that it wants to send back, say to a browser. And now I'm downstream. Up here I was upstream. And right here, if I want, I can change the body. Say it was an image and I just want to return the size of the image and not the image itself. And so I could change the content type that's going back. Maybe I see something in the body that I think is a problem. And so it actually gave me a 200 status here, but I'm going to change it and make it an error status. So all those kinds of things are possible. So now back to the server, I don't have any routes set up. I just have run, which is going to be used now for every path that comes in. And so I'm writing out that I'm handling the request, and I'm going to write out the path, and then I'm returning just the hello world content. And so the biggest thing I want to show in this example is the order that all of this code gets executed. So the first thing that happens is it says that my middleware is initializing. That's this line here, and it does that as soon as I say that I want to use that middleware. That's when it calls this and gets it initialized. And I also got that parameter foo passed. The second thing you see, I would have gotten in a request and it's going to run this code, but it doesn't do this first. The first thing it does is it runs through all of the middleware. And we'll see next that you can have more than one piece of middleware and the order that those things run. But the next thing you see is that I'm upstream. That's what you see here. And I could have changed the request. After that, now we're down here and I'm handling the request. That's because the middleware called the app. The app is this function right here. And so I'm handling the request. There's the path. It was just slash. And then I invoke the callback. But that's not going back to the person that sent the request yet, or the thing that made the request. Now I'm back here and I'm downstream. You see this line. And then I'm actually sending the data back. So very important to see how all this gets wrapped up. So this middleware was pretty simple, just had some console logs sprinkled in. I just want to point out the smallest piece of middleware you could write is what you see here. A middleware has to accept an app, but it doesn't have to take any parameters. And it has to return a function that takes an env and a callback, and then it must invoke the app and have all the signature that you see there and invoke the callback with those three things. Lots of rules to follow. And so there's this thing called the Strata spec that tells you about all of that. There's also a piece of middleware that's called Strata lint that checks all these things for you and tells you if you didn't follow one of the rules. This example I won't spend much time on, but the point of this is that I have, here's one middleware, here's another middleware, and here I've registered both of them. And in the output here you see what I get from that. And the interesting thing here is that I get middleware 1 upstream, middleware 2 upstream, and then I'm processing the request in the actual app. And then I get middleware 2 downstream, middleware 1 downstream. Notice how the order reverses there? And so what that means is that these middlewares are kind of like aspect-oriented programming wrapping of a function. So when you register more than one, each one is wrapping around the actual processing, kind of like that. And of course, the reason why I have this chunk and this chunk is this was what I actually asked for, slash. And then because I'm running in the Chrome web browser, it also makes a request for this favorite icon file. And so I'm seeing that second request come through as well. Right. Every separate request has to go through all that. Okay, one more thing I want to point out. I've shown some toy examples of middleware, but this is a real practical one. JSONP middleware. Now, just to give everybody some background in this in case you haven't looked into JSONP. The point of JSONP is to make it so that I can have code running in one web server, make a call to code in another web server, and it won't complain that I've violated the same origin policy. Well, the way this works is that it's doing a script tag injection. I'm adding to my web page a script tag that's going to make a request over to that other server, and what I'm getting back is not data, really. I'm getting back JavaScript code, which typically looks like a call to a function that's being passed the data. So I really just wanted the data, but instead I'll get this snippet of JavaScript code that's going to call a function that I've written. And magically, this gets around that same origin policy problem. So what I want here is I want to make it so that if I get a request and it has a query parameter named callback, then I'm going to act differently. What I send back will be different. So what we see in this example is I'm doing a bunch of streamy stuff here. And it seems like you shouldn't have to write all this code, but it turns out you do, just to have a basic stream in Node.js. So two things about this stream. The first is that it is both readable and writable. Both of those are true. And the other thing is that if I get a call to my write method, I'm just going to emit a data event with whatever data was passed in. And if I get a call to my end, I'm just going to emit an end event. So there's a lot to look at to really come to grip with streams in Node.js, but this is just a very basic example of a simple stream. And the reason that I need this is I need to hook together a bunch of things to do this JSONP. So if I want to send back, say, a simple JavaScript object that has a key and a value, then what I need to do is I need to have the name of some function that I'll call cb, and then I need this paren, and I need that. That's the JavaScript code that I need to construct. So when I'm ready to stream this back, I have this function, and I can pass it a stream, and the name of the callback, and the body, which is the data that I want to send back. So I'm going to say to the stream that I want to write out the callback name, then I want to write out a left paren, then I want to take the data that's in the body, and I'm going to assume that that's not a string, it's a stream of data that I'm sending back. And so I take that stream and I'm going to pipe it into this one. So that's just a very efficient way to take data from one stream and run it into another one. I need to tell it this configuration at the end of this, end false. If I don't do that, when it finishes piping the data, it will emit an end event, not only for itself, but it'll emit an end for the thing that I'm streaming into. And I don't want it to do that because I'm not finished yet. I need that closing paren on there. So when I finally get the end event on the body, that means it has finished doing that part of the streaming. And then I'll write out the write paren, and then I'll emit the end event on my stream. Okay, so I've got this bit of code that can stream out what I want. And finally, we can look at the middleware itself. So I'm going to build a request object from the environment. And the reason I'm doing this is I need to get to the query parameters. So if I call request.query, it will pass to this function the parameters. But maybe there was an error parsing the query string. And if there was, then I'm just going to return that error. I'm going to pass the error to the callback, and the return here means I'm done with this. I don't want to run the rest of the code. But suppose I didn't get an error. Then I go to the params and I see if there was one named callback. And I'm just holding on to that for now. And then I do the regular processing of the request, and I'm going to get some data back in the body here. Now, if you didn't specify that callback query parameter, then you're not trying to do JSONP. And so I'll skip down here and just return the data in the normal way. But if you did specify a callback, and I got a successful status from this, Then I want to do the JSONP thing. And so I create a stream. And right away, I'm going to send to the callback that it was a good status, not doing anything special with the headers. And then I'm passing back the stream. I haven't even written anything to the stream yet. Well, technically, you don't write to the stream. The stream is emitting a bunch of events. But I haven't emitted any events yet. But that's okay. I can still give that back because it's going to wait until I emit the end event on the stream before it thinks that I'm finished. And then I can go ahead and call that stream JSONP, give it the stream, the name of the callback, and the body, and it's going to stream everything through to that. Okay? So with this piece of middleware in place, I can support JSONP or not support it. So if I get requests that don't have the callback query parameter, it just runs in the normal way. But if that's present, then it does the JSONP thing. So that's kind of a practical example of when you might want to write your own middleware. Okay, so wrapping up real quick here, I mentioned this lint middleware. It's a good idea, but I've never been able to get the thing to work. The most useful thing about this slide is that it's explaining all the things that it could report, and so it's a good checklist of things that you should be trying to do in your code. Strata supports sessions and redirects and URL rewriting, content negotiation, file uploads, gzip encoding. So lots more than what I've had time to talk about tonight. And here's some references that you can look at later. So sorry we had to rush through that so quickly, but hopefully that gives you a good jump start if you want to look into this. And feel free to ask me questions about it later.
When you said the link thing doesn't work, what does it do?
Nothing.
You don't get anything.
It used to give errors that weren't correct. And I reported some of those to the author and he fixed them. And now that he's fixed it and I've tried the latest version, now when I do things that violate the spec, it doesn't do anything. I don't see any output at all.
So maybe your stuff's just perfect, you know?
No, I broke it on purpose. Yeah. So, any other questions? Yeah.
Sorry, this is a basic one. What is a streaming server?
So it just means that I don't have to get all the data and then send it out to the client all at once. It doesn't all have to fit in memory at once. That's the big issue here, is that I could give back a really large response and not have to worry about running out of memory.
So when you did it with the image, that was just one, that was just like, it was a small piece, but it could have been an image that was gigabytes.
Right, exactly.
Or 2-hour video presentation, radio stream.
Right.
And the really big advantage you can use a streaming server. It's easy to make a streaming server non-streaming, but making a non-streaming server streaming is like a miracle. So.
Right. Yeah.
And so Strata seems so flexible. Do you see it becoming the de facto server for Node.js?
I would like it to become the de facto, but unfortunately it's got, Express came out first, and so it's got the most mind share, and this is less known.
And I'm just beginning with this.
Yeah,
So I was working on a project we ended up using Nginx plus Node. So if we do Strata instead, we wouldn't have to done Nginx, right?
I believe that's right.
Is that how most people deploy it? Is Strata's at the front and not behind Nginx?
You can do that, but you can also layer them if you want.
What is more typical, would you say?
It depends on what you're doing. You know, it depends on whether, Nginx's file serving is probably slightly faster than Strata or anything else that's going to be node-based because it's eliminating the JavaScript processing, garbage collection and all that. And the other thing that Nginx would be good for, or unless you're using something else, is for SSL. So Node does SSL, but it's got some things that it doesn't do as efficiently as like Nginx does. And they're working on that for the next version. But for now, if you got really a lot of SSL, and high performance, then you might want to have something in front of it that's taking care of the SSL part. So, but if you don't have those types of issues, or your throughput's not that really that huge, then you might just go with straight Strata. I mean, and in the future, that's going to be probably more possible because after they fix the SSL thing.
So Mark, what do you guys actually use this stuff for right now?
Well, so it is our main server software that we're using for our project, but It's hard to say what exactly we're using it for. We're kind of a project without a real specific client yet. We're building a framework for building applications on top of. There's one group that's building an app on our framework right now, and others to come. So it's hard to talk about specifics of what we're using it for.
But we are building a lot of things as small layers, and that fits really good with Strata's middleware concept. And so little pieces do one thing, and so there's a lot of those. So that fits really good.
Yeah, but I wasn't sure if I followed like in a large web application where you've got different parts with different little URL prefixes getting different. Do you wind up using like multiple modules with different middlewares applied in different sections of the overall structure of the URLs?
Yeah. So I guess maybe a key thing to point out there is that in different JavaScript modules, every time you do a require on Strata, you're getting the same thing back. And so it's not a problem for multiple modules to be registering routes. It'll all be handled by that same Strata object.
And that relates to my question though, is there ever a need where you truly want to apply different middleware to different routes that I'm using?
Yeah, you can do that. You can have middleware that runs only in specific routes, and there's also a middleware that's called URL map that allows you to map more globally. Like you can use domain or host names, and you can basically map virtual file systems onto the routes and that. So different way of doing routing, but yeah.
Right.
Yeah. Another cool thing that this has, like over something like Express, is the mocking. Because Express gives you back the nodes server, which you can only pretty much use by starting it up, and so you got to use curl or something. You got to run your tests with with actually a server running and starting up. Whereas Strata can actually, since it's a layer, it's an abstraction, it's actually got a mock, and so you can not have to run a server, and you can pass in whatever you want, and so without even using curl or anything, you can simulate any situation that you want to pass in, good or bad. And see what the server can respond with without having to start up, TCP and all that. So it's kind of nice.
So my guess would be, go ahead, sorry.
So for you, just
Exactly, yeah. So you can write all these unit tests and test every type of scenario, authentication, not authenticated, any kind of URL request, good and bad, garbage, whatever, and you can see how it's going to respond. And it's very fast too, because you don't have to start up all the other stack.
I was just going to say, somebody asked about this versus Express or whatever, or is this going to dominate? I like what I see. It looks extremely flexible. But as you noted a couple of times, there's an awful lot of rules and moving parts, and a lot of it has to do with the necessary evil of, bringing streams into the core of the thing, learning all the rules about what you have to set up and what you have to pass on. My guess is a lot of developers just aren't that dedicated, and they look at Express and they say request, response, next. And that's it. It's much easier to Lego block it. This one doesn't look like it's still, you can Lego block it, but you have to learn all the rules about the different connectors for the Legos.
Right.
So,
and there are people they're debating how to try and move Express and connect forward. They like to keep that same simple pattern, but how do you give it basically the ability to modify the streams on through all that. So I hope they can come up with something, but right now it's kind of anything that wants to use streams with Express is kind of monkey patching, and it's kind of a mess. But
I'd say there's not that many rules to learn though. It's like what does a middleware look like? They all kind of look the same in the basic structure. And what do you pass to the callback?
yeah, no, it doesn't look bad, but I think it would be enough of a hump.
Right.
Where some people are just going to turn away because they say, whoa, right? It's too much.
It reminds me of Rack middleware that's kind of the same way, where it seems like intimidating at first, but once you do a couple, it's really like, it's easier than you would ever think. It's like confusing because it's so easy.
Rack,
You would think it would be hard, and it's not.
Yeah, it is. It's a combination of, Express was also inspired by Sinatra, but yeah, you get the Sinatra influence, you've got Rack and WSGI from Python. All those are kind of combined into this. It's kind of,
But finally they got streaming, which
exactly.
did not.
Yeah.
All right, we're going to get.
Thank you so much. That was great.